Hi, this is the part one of analyzing pattern, and in this part we'll discuss about the average nearest neighbor. And there is something about me. I'm Dr. Zubairul Islam. I'm working in Aligarh at the University in the Department of Geography. The average nearest neighbor, in short, we can call it as ANN. This is equal to the ratio of DO divided by DE, where DO is the observed mean distance between each feature and its nearest neighbor. This is observed, which is actual given in your data, the distance, the mean distance. And the DE is the expected mean distance for the feature given in a random pattern. So this is about DO and DE. And the average nearest neighbor z-score for the statistic is calculated as z equal to DO minus DE divided by SE. So as we know, DO is observed distance, DE is expected distance, and the SE is here standard error. And the standard error thereafter. Okay, then here I'm open with my software ArcMap. On the left hand side is the table of content where my data is. On the right hand side is the toolbox. So let me introduce my data first. Here, this data belongs to Tigra region, and within Tigra region, these are the major settlements, the urban settlements. So my interest is I want to know that what is the pattern of these urban settlements, and there are three options. The pattern may be random, it may be dispersed, or it may be clustered. So when we will see the result, it will be clear to us. So before I start, as we were talking in the formula, that observed distance, what is the observed distance and how it is calculated? You see, these are the urban centers, and the location of urban centers is given here. And my interest is to know, actually, as a geographer, or if you are interested in geography, your primary concern, one of the first objectives should be that what is the spatial pattern, how it is distributed. It should be your first objective, should be, because when your first objective will be cleared, like whether it is clustered, then the second objective, the why it is clustered here, that will be your second study then. So this is the importance of this work, to know, as being a student geography, you must know that how any phenomena is distributed. Is it dispersed? If it is dispersed, it is randomly distributed. So if it is randomly distributed, maybe it will be difficult to answer the question why it is distributed randomly, or maybe. But if it is clustered, then why it is clustered here? Why? Then there may be some explanatory variables which can explain you that why it is clustered here. So in this analysis, as in the formula it was discussed, observed distance. What does it mean, observed distance? Nearest neighbor. Nearest neighbor means, suppose here, these are the two settlements. So let me take the name of the settlements. Suppose here these are the two settlements, Alamata and Karem. So what is the distance here in between these two? Around 11 kilometer. So for this, nearest is 11 kilometer. What about this mature? So mature distance will not be calculated from here, remember. This is not the nearest. Nearest is this. So it will take distance from here. This is around 12 kilometer. And what about this Chet? There is a place here from where it will be taken. It will also take the nearest distance. So nearest is not this. This is the nearest. So it will take 23 kilometer. So all these distances, nearest distances, will be divided by the n, the number of settlements. So it will be the mean observed distance. And this mean observed distance, again, mean observed distance will be divided by the expected distance. So if all these points are randomly distributed, then what should be the expected distance considering this area of the region? So here, this is the way the software calculate observed distance divided by expected distance. Then there is a which we have already discussed before, which is the nearest neighbor distance. So let's do it, and we will see the pattern. For that, I will use a special statistical tool, then analyzing pattern. Within analyzing pattern, this is the average nearest neighbor. Here I will take my feature class, and of course I have to generate report because this is important for me. And the area is optional. If you will leave it, then it will take only the boundary covering all these points. Otherwise, for better analysis, you can give the area of the Tigray region. This is the shape area. Here you can give the whole area like this. This is capital A in the formula. Thereafter, you will hit OK. So it is done, and it will not produce any map, but it will give you a report, very good report, which you can read. So to see the result, geoprocessing, then go to results, thereafter average and nearest neighbor, and go to messages. Here in the messages you will find the location of your report which you have generated here. So here I can see the report. Yeah, here it is, nearest neighbor results 2. I will right click and I will open with, because this is HTML file, then you can open it in Google Chrome. In Google Chrome you will see the result like this, and this is the average nearest neighbor summary here. So this is a normal curve, and in this curve, if you see the observed nearest neighbor ratio, this is 1.17580. Okay. By the way, it is important to note that if the index average nearest neighbor ratio is less than 1, the pattern exhibits clustering. If the index is greater than 1, the trend is towards the dispersion. And if it is in between, then it is a random. So this is the observed distance divided by expected distance. So the observed distance was this, means on an average all the settlements are around 22 kilometer far away. This is the nearest neighbor distance, mean distance. Expected is, it was like this. expected was this. So if you will divide, then the ratio is this here. So as we have discussed before in the formula, if you will calculate the z-score, here z-score will come as 1.99. So 1.99 will lie in this section here, orange color. This is the dark orange color. So when it will lie here, your p-value is 0.05. What does it mean? 0.05 means 5%. So you can see the answer here, that given z-score of 1.99, that there is less than 500% likelihood that this dispersed pattern could be the result of random chance. So when you are working or you are doing some research, then you can formulate the hypothesis that the distribution is not dispersed, something like that. So it will be your null hypothesis, and with the help of this result, you can reject your null hypothesis, and you can say that the pattern is, you are 95% confident here. If you will, this is 5% likelihood that it could be a random chance. So if this is a 5% likelihood could be the random chance, then how much is left? The left is 95% sure. You are confident here that the urban settlement in Tigray region, the pattern is dispersed, and you are 95% confident for that. So this was all about the average nearest neighbor analysis. In the next video, we will talk about the clustering. Then this is finished here. Thanks for listening and thanks for watching.